Welcome to the deep dive. Today we're diving into something pretty incredible.
Incredible how.
Incredible because it's changing so many things around us, maybe even without us realizing it. We're talking DNA and gene cloning services. Yeah, the global market for it.
Fascinating area, and it's one that's, frankly, moving at lightning speed.
You're telling me you sent over some really interesting stuff to get us prepped for this. That report, what was it called again? The Global DNA and Gene Cloning Services Market Report 2025, right?
That's the one. It's from Cognitive Market Research. Report ID is CMR 687395, and it was just updated a couple of months ago, February 2025.
Right. February. Super recent. And then we also saw those announcements from GenScript and Twist Bioscience about their new, super fast gene synthesis services.
Yep. GenScript launched FLAHSH gene synthesis back in June last year, and then Twist Bioscience followed with Twist Express genes in November.
Okay, so we got all that, a lot to cover. Our mission today, though, is to distill it down. What are the key takeaways? What does all this data, all this news actually mean for us? What's the big picture?
And maybe the most important takeaway right out of the gate is the sheer size of this market. In 2025, this year, it's already projected to hit, get this, USD 356.28 million. That's huge.
Wow, and where's that number headed?
Hold on tight because it's going to blow your mind. By 2033, they're projecting it to reach USD 9755.040685 million.
That is a lot of zeros. So we're talking, what, almost a tripling of the market in less than a decade?
Exactly. And that translates to a compound annual growth rate, a CGR, of 14.70%. That's not just growth, that's serious acceleration.
And what's the engine behind all of this? I mean, what's fueling this phenomenal growth?
Well, a lot of it boils down to this increasing demand for personalized medicine. It's not science fiction anymore. It's becoming reality, and it's driving a lot of investment and innovation in this space.
Yeah, that makes sense. So where are we going to go from here? What's on the agenda for this deep dive?
Well, we should probably start with a bit more of a breakdown. Where's this growth happening geographically? What types of DNA and gene cloning services are we talking about specifically? Where are they being used, and by whom? Get into the nitty-gritty.
Right, let's zoom in on those details. So let's start with that USD 356.28 million market size in 2025. And that, what was it again? 14.7% annual growth rate.
14.7% through 2033. A lot of momentum there. It really tells us this is more than just a niche area. It's becoming core to a bunch of industries.
Okay, so let's break it down by region. And I think it won't be a big surprise that North America is leading the pack. Over 40% of the global market share, coming in at USD 1,204.82 million this year.
And even with that huge chunk already, they're still looking at a pretty healthy CAGR of 13.1% through 2033.
Right, they're not slowing down anytime soon.
Right.
And obviously, the U.S. is the big dog in North America. They're projected to be a USD 950.61 million market all on their own, with a 12.9% CAGR.
Yep. And then you have Canada, a bit smaller, but growing steadily at USD 144.58 million with a 13.9% CAGR, and then Mexico at USD 109.64 million with a 13.6% CAGR. Pretty much all in the same ballpark there.
So what is it about North America? Why are they so far ahead in this game?
It's kind of like a perfect storm, honestly. They've got this super strong biotech sector, lots of innovation, tons of companies pushing the boundaries, and there's a huge demand for gene therapies, new ways to treat diseases that haven't had good solutions before. Plus, you've got tons of investment pouring in, both from the government and private companies, and their healthcare system is already set up to adopt these new technologies pretty quickly.
Makes sense. Okay, so let's jump across the pond to Europe. They're holding steady in second place, over 30% of the global market, USD 944.32 million this year, and a very respectable 13.7% CAGR.
Very respectable, for sure. And like North America, some specific countries are really driving that growth.
Yeah, let's hear it. Who are the European powerhouses in this market?
Well, the UK is definitely up there. They're looking at USD 158.65 million this year and a strong CAGR of 14.5%. Germany is another big one, USD 186.98 million with a 13.9% CAGR. France, also pretty significant, USD 86.88 million and a 12.9% CAGR.
So the usual suspects. Anyone else worth mentioning?
Oh, yeah, definitely. Italy's in the mix too, USD 81.21 million and a 13.1% CAGR. Then you have Russia, USD 146.37 million with a 12.7% CAGR, and Spain at USD 77.43 million, growing at a rate of 12.8%. Even some of the smaller countries like Sweden, Denmark, Switzerland, even Luxembourg, they're all showing impressive growth numbers.
Yeah.
And then if you lump all the rest of Europe together, that's another big chunk of the market.
Pretty much, they've got a great foundation in biotech R&D, a history of scientific excellence, lots of research funding, both public and private, and like everywhere else, the need for new and better gene therapies is pushing things forward. It's amazing how consistent those drivers are, regardless of where you look. But now let's go somewhere a little more, maybe a little less predictable. Asia Pacific, or APAC, right now they're only at around 23% of the global market, USD 781.51 million in 2025.
But here's the kicker. Their projected CAGR is a whopping 17.6%. That's the highest across all the regions.
Wow, that's huge. So they're catching up fast. What's going on over there?
Oh man, so much is happening in APAC. It's a real hotbed of activity. China, as you might expect, is leading the charge. Their market is expected to hit USD 328.23 million this year, and they're growing at a rate of 17.1%.
So they're right on par with the overall APAC growth rate.
Yeah, then you've got Japan, a bit smaller, but still a big player at USD 107.85 million, growing at 16.1%. South Korea, another significant market, USD 93.78 million, 16.7% CAGR.
And what about India? They've been making a lot of noise in the tech world. Are they a factor here too?
Oh, absolutely. India is actually one of the fastest growing markets. They're projected to hit USD 78.15 million this year, but with an EGR of 19.5%, almost 20% annual growth. That's incredible.
Yeah, that is really something.
Yeah.
Why are they growing so much faster than everyone else?
It's a few things, really. First off, they're pouring money into building up their biotech infrastructure, research facilities, universities, training programs. And there's a huge and growing demand for personalized medicine, especially given the size and diversity of their population. Plus, India's got some really bright minds doing cutting-edge genetic research, and the government is very supportive. They see this as a key area for future growth.
Okay, so we've got North America, Europe, APAC, all really taken off. What about South America? Are they in the game at all?
Oh yeah, they're definitely players, though a bit smaller for now. Currently, just over 5% of the global market, USD 123.74 million this year, but their CAGR is a very respectable 15.4%.
Not bad at all. Any particular countries leading the way down there?
Brazil is the big one. Their market's projected to be USD 52.96 million this year, with a CAGR of 16.0%. Argentina's next, USD 20.79 million and a 16.3% CAGR. And then you've got Colombia, Peru, Chile all contributing to the growth. It's really the same story as other developing regions. Investments in biotech are increasing, the demand for gene therapies is rising, and there's a lot of exciting research happening.
All right, so last but not least, we have the Middle East and Africa. I'm guessing they're starting from a bit further behind.
Yeah, they're both still relatively small players in the overall market. The Middle East is at about 2%, so that translates to USD 138.25 million in 2025, with a CAGR of 16.1%.
So good growth potential there.
Definitely. Saudi Arabia is a key market in the region, followed by the UAE, Turkey, and Qatar. Investments in biotech are on the rise, there's growing interest in personalized medicine, and several governments are actively supporting genomics research.
And what about Africa?
Africa's sitting at about 1% of the market, USD 71.64 million projected for this year. Their CAGR is a solid 15.0%, and there is a lot of potential for growth, particularly in South Africa and Nigeria.
Makes sense. So it seems like pretty much everywhere you look, there's a lot of excitement and investment in this field.
For sure. It's becoming a truly global phenomenon.
Okay, so now that we have a good sense of the, geographical landscape, let's dive into the actual services themselves. And I think it would be helpful to understand what the main types of DNA and gene cloning services are, because the report highlights gene synthesis as the dominant one, which is interesting. So can you explain a bit more about that?
Sure. Gene synthesis, it's basically like, imagine you want to bake a cake.
Okay, I'm listening. I like cake.
Right. But instead of using a recipe that someone else came up with, you design your own with exactly the ingredients you want to get the exact flavor and texture you're going for. That's kind of what gene synthesis is like. Researchers can order custom-designed DNA sequences, like ordering specific ingredients, instead of having to extract them from existing sources.
I see. So you're not limited to what's already out there. You can create something entirely new.
Exactly. That's a big advantage. No need for a template DNA, which is a must for traditional cloning. And that saves tons of time and effort, especially if you're dealing with complex genes. Plus, all the advancements in automation and now AI, they're making gene synthesis even more precise and efficient.
So basically, scientists are becoming like master chefs of DNA, whipping up whatever they need.
It's a pretty good analogy, honestly. And think about the possibilities. Gene synthesis is crucial for all sorts of things. Synthetic biology, where they're engineering completely new biological systems, drug discovery, personalized medicine. It's really the foundation for a lot of the most exciting developments in biology.
Wow. And it seems like it's only going to become more and more important as time goes on.
Definitely. As the demand for genetic engineering grows and as gene synthesis gets more affordable and faster, it's really cementing its place as the top dog in this market.
Okay, so we've got gene synthesis. Now, the report also mentions custom cloning as a rapidly growing segment. What's the story there? What's driving that growth?
Custom cloning, it's all about getting very specific, very tailored genetic modifications. It's like taking that cake recipe analogy and saying, okay, we want to tweak this one ingredient just a tiny bit to see how it changes the entire cake.
Interesting. So more precision, more control over the final product.
Exactly. And that level of control is super valuable for researchers and biotech companies who are working on really specialized applications. Personalized medicine, synthetic biology, advanced gene therapies, those kinds of things. And the rise of gene editing technologies like CRISPR, that's been a real game changer.
Oh yeah, we hear about CRISPR all the time these days.
Yeah.
How does that fit into custom cloning?
Well, CRISPR allows for super precise changes to the genetic code, like editing individual letters in that DNA recipe book. It's incredible. So you can study specific genes, engineer new biological tools, all sorts of things. And with all the advances in automation and AI, custom cloning is getting faster and more affordable all the time.
So this is really giving scientists the tools to like really fine-tune the building blocks of life.
Yeah, that's a good way to put it. And that's why it's in such high demand, especially in areas like drug development, agricultural biotech, industrial biotech, you name it.
All right, so just to round out the picture on the types of services, the report also mentions subcloning, but I think that's more of a traditional technique, right? It's not quite as flashy as gene synthesis and custom cloning.
Yeah, you're right. Subcloning is more about moving a specific piece of DNA from one vector, which is like a little DNA vehicle, to another.
So kind of like copying and pasting a file from one USB drive to another.
Yeah, that's a good way to think about it. It's still a necessary step in a lot of research, but it's not where the real innovation and growth are happening right now.
Gotcha. Okay, so we've covered the what. Now let's talk about the how. How are all these DNA and gene cloning services actually being used? And the report points to DNA sequencing as the dominant application. Why is that? I mean, we hear about DNA sequencing all the time, but it's easy to forget what it actually means.
DNA sequencing, it's basically like reading the code of life. Imagine you have this huge instruction manual that tells you how to build a human being or a plant or anything else that's alive. DNA sequencing is like being able to read that manual to decipher all the instructions.
So pretty important then.
Absolutely. And it's become essential for pretty much all of modern biology and medicine. Basic research, disease diagnosis, developing new treatments, agriculture, biotech, you name it. And next generation sequencing, or NGS, that's been a real game changer. It's made DNA sequencing way faster and cheaper than ever before.
So that's why it's so widely used now, because it's become more accessible.
Exactly. And the more we sequence, the more we learn. It's the foundation for personalized medicine because it allows us to understand each person's unique genetic makeup. It's crucial for gene editing because you need to know exactly where you're making those edits. And it's driving all sorts of amazing research.
So it's not just a tool, it's like the foundation for a whole new way of looking at biology and medicine.
I'd say so.
Yeah.
As sequencing technology continues to improve, it's really driving innovation across this entire field.
Okay, so DNA sequencing tells us what's in the DNA code. Now, what about actually changing that code? The report also mentions mutagenesis as a rapidly growing application. What's that all about?
Mutagenesis is all about intentionally making changes to the DNA sequence, like going into that instruction manual and editing a few words to see what happens.
Interesting. Sounds kind of risky.
Well, it's all very controlled, of course, but it's a super powerful way to figure out how genes work. Like, what happens if we tweak this gene just a little bit? How does that change the organism?
So it's like a way to experiment with the code of life.
Exactly. And it's also crucial for engineering proteins with specific properties, for developing new therapies, all sorts of things. And technologies like CRISPR have made it so much easier to do this with incredible precision.
And I guess that precision is why it's becoming such a popular technique.
Exactly. And as we understand the genome better and better, the ability to make these targeted changes becomes even more important.
Okay, so we've got sequencing, we've got mutagenesis. Anything else we should know about in terms of applications?
The report also mentions genotyping, but that's a bit more specific. It's about looking at certain spots in the genome to identify variations. It's often used for diagnostics or in breeding programs.
Okay, so important, but not quite as broadly applicable as sequencing and mutagenesis.
Right. Those are the real stars of the show when it comes to applications.
Okay, so now let's talk about the who. Who's actually using all these DNA and gene cloning services?
Hmm.
And the report says academic and research institutes are the biggest consumers, which makes sense, right? They're the ones pushing the boundaries of knowledge.
Yeah, totally. They've been at the forefront of this field for decades, and they rely heavily on these services for their research. Drug discovery, engineering new biological systems, studying diseases, they do it all. And they're often funded by government grants and other research organizations, so they have the resources to invest in these cutting-edge technologies.
And they're also training the next generation of scientists, so it's like a self-perpetuating cycle.
Exactly. They need these tools to do their work, and they're passing on that knowledge to their students who will then go on to use these technologies in their own research and careers. It's a really vital ecosystem.
So it's not just about the science itself. It's about the whole infrastructure of knowledge and training that supports it.
Totally. And that's why academic and research institutes are such a crucial part of this market.
Okay, so that's the academic side. Now, the report also highlights pharmaceutical and biotech companies as a rapidly growing segment. And given all we've talked about with personalized medicine and gene therapy, that seems pretty logical, right?
Oh, yeah, it makes perfect sense. They're the ones taking the discoveries from the lab and turning them into real-world treatments. And they're increasingly relying on DNA and gene cloning services to do that.
So it's like a handoff from the research world to the commercial world.
In a way, yeah. And the demand for things like recombinant proteins, monoclonal antibodies, CRISPR-based therapies, it's all exploding. Plus, they're investing tons of money in R&D, and there's a lot of collaboration and even mergers happening as companies try to stay ahead of the curve.
It sounds like a really dynamic and competitive space.
It definitely is. And all the advancements in automation and AI, they're making it easier and cheaper for these companies to develop new products. So it's really a perfect storm for growth.
So we've looked at the regions, the services, the applications, the users. Let's zoom out again and talk about the big picture. What are the key drivers of this growth? The report was a few, right?
Yeah, a few interconnected ones. First off, all the innovations in core technologies like CRISPR, PCR, next generation sequencing, those are like the building blocks of this whole field, and they're constantly being refined and improved.
So better tools lead to more progress.
Exactly. Then you've got the growing demand for gene therapies. People are desperate for new ways to treat diseases that have been incurable for so long. And personalized medicine is another huge driver. The idea of tailoring treatments to each person's unique genetic makeup, that's a really powerful motivator.
And of course, you can't do any of this without money. So investments are key too, right?
Absolutely. Both governments and private companies are pouring money into genetic engineering projects all over the world. Without that funding, this field wouldn't be nearly as advanced as it is.
But even with all that momentum, there must be some challenges too. The report mentions a couple, right?
Yeah, a few things to keep in mind. First off, the cost. All the equipment, the reagents, the trained personnel, it can be really expensive to get started in this field, especially for smaller labs or companies in developing countries. That can definitely be a barrier.
So a bit of a rich get richer situation.
In a way, yeah. And then there are the regulations. Gene therapies and other applications have to go through a really rigorous approval process, and that can take a long time. It's necessary, of course, to make sure everything is safe and effective, but it can definitely slow things down.
So navigating those regulatory hurdles is a big part of the game.
Absolutely. But despite those challenges, the overall outlook is really positive. I mean, this field is moving so fast. There's so much potential.
Yeah, the report also talks about some key trends shaping the future of this market.
Hmm.
What are some of the things we should be watching for?
Well, the precision gene editing revolution is only going to get bigger. CRISPR and other technologies are changing the way we think about manipulating DNA. It's incredible how specific we can be now.
So we're moving from a sledgehammer to a scalpel.
Exactly. And that's going to lead to all sorts of amazing new therapies and applications. The other big trend is the push towards personalization. The demand for genetic tests, personalized therapies, it's only going to grow. People want healthcare that's tailored to their individual needs, and that's where this field is headed.
So the future is personalized and it's written in our DNA.
I think so, yeah. It's a pretty exciting time to be following this space.
Before we wrap up, let's touch on the players in this market. The report mentions a few key companies, right? And we talked about some recent product launches too.
Yeah, the market is pretty competitive, with several companies vying for the top spot. Thermo Fisher Scientific, GenScript, Biotechnology, Charles River Laboratories, Eurofins, those are some of the big names. And they're all focused on innovation, trying to stay ahead of the game.
And those recent launches, they're a good example of that, right?
Definitely. GenScript's FSH gene synthesis service, that's a big deal. It promises much faster turnaround times for creating synthetic genes, which is huge for things like vaccine development, antibody drug discovery, cell and gene therapies. And Twist Bioscience's Twist Express genes, that's another big step forward. It gives researchers quick access to high-quality genes and gene fragments, which can speed up research in all sorts of areas.
So speed and efficiency are key in this game.
Absolutely. The faster you can move, the more competitive you are. And that's especially true in a field like this, where new discoveries are happening all the time.
So as we wrap up this deep dive, I think it's clear that the market for DNA and gene cloning services is huge and only getting bigger. And it's not just about the money, it's about the potential to really change the world.
Totally. And it's all driven by this incredible combination of technological breakthroughs and the growing demand for personalized medicine.
Yeah, it's a really exciting time to be alive, especially if you're interested in the future of healthcare and biotechnology.
It makes you wonder, though, with all these advancements happening so fast, what's next? What breakthroughs are just around the corner? What fields are going to be completely transformed by these technologies?
Yeah, it's hard to even imagine what the future holds. But one thing's for sure, it's going to be amazing. Thanks for joining us for this deep dive. It's been a fascinating conversation.
My pleasure. It's always fun to explore these topics.
Until next time, stay curious.